Hey, so today we're going to tackle a question that honestly sounds like it's straight out of a sci-fi movie. How in the world do you launch a whole bunch of satellites from one rocket without them all just smashing into each other? But before we dive into that cosmic ballet, just a quick legal note.
Okay, with that out of the way, let's get right into it.
I mean, really, have you ever stopped to think about this? You hear about SpaceX or someone launching 8, 20, even 60 satellites in one go, and you kind of have to wonder, how do they let them all go without creating this spectacular, high-speed demolition derby up in space?
So to get our heads around this, we're not just going to talk theory. We're going to look at a real-world example. AST SpaceMobile and their Bluebird satellites. These things are pretty big, and they get launched in groups, so they're a perfect case study for understanding the insane level of precision that's involved here.
First things first, let's just take a moment to appreciate the scale of this problem. This isn't like dropping packages off a truck. We are talking about deploying incredibly complex, expensive technology at speeds that are just, well, they're mind-boggling.
Once they're up there at their target altitude, these satellites are whipping around the Earth at 7.6 kilometers per second. To put that in perspective for you, that's almost 28,000 kilometers an hour. At that speed, even a tiny little tap between two objects would be completely catastrophic.
So, on one hand, you have the goal, a perfect, beautiful, orderly deployment. And on the other hand, you have the absolute nightmare scenario, a chain reaction collision that turns billions of dollars of amazing tech into thousands of pieces of deadly space junk. The stakes just could not be higher. So, how do they pull it off?
Well, it might seem like magic, but it's not. It's actually something even cooler. It all boils down to a few brilliant, yet surprisingly simple secrets of orbital mechanics. 3 really elegant engineering tricks that make sure everything goes off without a hitch.
And here they are, the 3 secrets. First, you release them one by one, not all at once. Second, you give each one a tiny, very specific push. And third, that little push is just enough to put each satellite into its own unique orbit. Now let's break down exactly how that works.
So secret number 1 is probably the one you'd guess, but it is absolutely fundamental. You don't just, open the cargo bay doors and let them all tumble out. No way. The dispenser that holds the satellite spits them out sequentially, one after the other, with carefully timed gaps. Sometimes it's seconds, sometimes it's minutes, between each release.
Now for secret number 2. This is all about a cool concept called relative velocity, or if you want to sound like a rocket scientist, you call it delta V. All it means is the tiny controlled difference in speed you give to each satellite as it's released. It's really just a gentle nudge. Now that might not sound like much, but in the vacuum of space, even the smallest push has enormous consequences over time.
And when I say gentle nudge, I really mean it. We are talking about a change in speed of just, get this, 0.1 meters per second. That's slower than a casual walk. So you're probably asking, how can something so small make any difference when you're already going thousands of kilometers an hour? Well, believe it or not, that tiny push is the key to this whole thing.
And hey, just a quick pause. If you're enjoying this explainer and learning something new, it would be a huge help if you could take a second to hit that like button and subscribe. It genuinely helps us make more content just like this, and hey, it's totally free for you. Thanks a lot.
Okay, and that tiny little push we were just talking about, that leads us straight into our third and final secret. See, that nudge does way more than just create a little bit of immediate space. In orbital mechanics, if you change an object's speed, even by a tiny amount, you change its entire orbit. So each satellite gets pushed into its own unique orbit, just infinitesimally different from all its siblings.
And this is where the real magic happens. It's where the engineers get to, kick back a bit and let the fundamental laws of physics do all the heavy lifting for them. This beautiful process is called a long-track separation. And the effect of that tiny, slow-walking pace nudge? It just balloons over time. It's amazing. After just 1 hour, the satellites are already hundreds of meters apart. A day later, that gap has grown to several kilometers. And within a week, they are spread out over a huge, safe distance, all from that one initial, gentle push. So the most important point here is that this separation happens naturally. There are no engines firing, no complex maneuvering commands being sent from the ground. The satellite with a slightly faster orbit starts to lap the others, and the one with a slightly slower orbit falls behind. They just spread out all by themselves. It's efficient, it's elegant, and it's just incredibly clever. So let's bring it all back home. What looks like this impossible traffic management nightmare in space
is actually solved with a kind of planned magic. It's all just based on a really deep understanding of physics.
So, to recap the recipe for not crashing your billion-dollar satellites, you release them one by one, you give each one a tiny, precise push. That puts them all in slightly different orbits, and then you just let physics do the rest, creating a safe, natural separation over time. It's as simple and as brilliant as that.
And that's really the heart of it, isn't it? What so often looks like magic when we talk about space technology is really just well-planned, brilliantly executed physics. It's a fantastic reminder that with enough smart thinking, even the most daunting challenges can have really elegant solutions. Thanks for hanging out with me today.